Daniel, welcome on, and Elliot, thanks for joining. So, in my favorite fashion, this conversation was sparked by interest on the internet, and um, I did want to dive into BIPV and facades and so forth. We'll get into the specifics, but I like throwing kind of topics out there and seeing what sticks, and this one stuck. And you seem to be the fan favorite to get on here. So, before we dive into it, welcome, Daniel, and thanks for hopping on.
Thanks for having me, Adrian. It's always fun to comment on your post online and engage with all the insightful information you have.
Thank you. And yeah, this is a super relevant topic, and Elliot's a good friend, and if you guys haven't met, Elliot's been in the industry, I'd say forever, but he doesn't want to hear me say that. But
Okay.
testing facades, strong understanding on the sort of deep energy retrofit side, energy modeling side, the glazing side, the cladding side. So I think he's going to be able to provide really good insights here. But I want to get technical, and we're going to ask some hard pressing questions, which I'm sure you'll be able to handle. But before we get into that, what if you had to give, you're speaking to anybody on an elevator, 30, 60 second, 90-second pitch, my head would go solar panels on a facade. But how do you explain what it is that you do?
I mean, the explanation is in the name. It's a building integrated photovoltaic or building integrated solar. It's a hybrid dual purpose material. It acts as a building material as well as the power generation, basically converting the buildings into a power plant.
So the concept has been around forever. I guess the question is, what have you seen from an execution standpoint? Because that's a real question here. Some people say it's science fiction. Some people say, how effective is it? From a performance or output standpoint, some people say, is it cost competitive? So is there something that you were picking up on in the industry and essentially something that you're trying to do different?
Yeah, so it's one of the most misunderstood material, in my opinion, in construction. It has always been tackled and answered by solar companies who are not construction companies. They don't understand the architectural language. They come to the space with this 4-inch by 4-inch super cool pictures and a glass that's never going to go on a job site, that's never going to get integrated into any curtain wall. They do not answer the critical questions of the consultants. What happens to the heat dissipation? What happened to the electrical wires? What happened to the fire testing? None of them are answered. It's just a solar panel that they can put some colors on it or no colors, and they call it BIPV. So every single conversation that we start, typically, if you are talking about drywall, we start from 0 points. Drywall A, B, C, and then we can compare. We have to start from negative. We have to first fix all those misunderstandings, get to the even ground, and now I can build the trust and talk about what's in this material, which, I have seen it in many meetings. It kind of follows with, it's too good to be true. It doesn't make any sense in the beginning. It's impossible, the claims that you guys are making. It's too good to be true. And then we have third-party testing, case studies. It's a slow grind in the beginning, but once it clicks, then everybody comes to the conclusion it's a no-brainer. Why haven't we done this for the past 20 years? Which, we can go through the answers, and I can tell you step by step why it hasn't taken off, what's preventing it from taking off with all other companies, and what are we doing differently that's getting traction.
So I'm sure, like every new technology or innovation or new way of doing things, getting your first big commercial project or high-end project or something that you could show people was everything for you, just in terms of ease of sell and eliminating some of those objections. What would you consider to be your first big win?
The first big win to me that actually showed that this product is real, we can install it and it produces electricity, was a church retrofit we did in Toronto. Pre-assembled panels about 20 feet long, BIPV, installed by a crane, connected to the roof panels, and everything came together. To us, that was a proof of concept. We produced it, we assembled it, we installed it with a crane. Everything worked out, the wiring, connection, everything was in the right place. So that was our first proof of concept until we went to the next one, which was a retrofit project, again in Halifax, residential, on one side of the tower. That was the first high-rise project. I think it was 30, 40 story, and that ended up being a successful project. Now, we have many, many projects after that, but the initial one a few years ago was those critical the smaller projects.
And how in depth are you getting with sticking with those either building owners or operators and sort of assessing like how effective is this really in practice? Our sort of performance understanding or projections, are they in line, and how off are we?
Yeah, it's funny that you asked. We go through this on an annual basis with them. We get a report and we compare with our initial estimation. One of the buildings we were looking at June that was actually higher than the first year we installed. The production was higher than the first year. There is another misconception that people think, BIPV and solar degrade on a linear basis. That's really a theoretical degradation of the material. It's not realistically what happens every 5 years. We might have a better year, we might have a lower year, but on average, we expect a certain degradation just because of the nature of the silicon. So we are monitoring them on annual basis, sometimes on every quarterly basis, depends on their needs. And mostly we have an API, we bring it to our kind of platform. So we keep track of the energy generated through them.
You're eliminating some of the maintenance issues being in the vertical plane too, right?
There is almost no maintenance. In our factory, the building I'm sitting in, the production line is right behind me. We have a complete solar roof, which is about 600 kilowatt solar roof on our factory. And then we have a smaller section on the side of the building, which is about 120 kilowatts. Our roof was invaded by seagulls and birds. So they nested, they went over the solar panels, and our accounting actually flagged it. They said our electricity bill has gone up by 50%. So they started looking into it. Why is our electricity bill has gone up? Then someone went on a roof. They said, well, we lost the solar panels to seagulls. That's on the roof. But on the side of the building, spotless, it's clean just because it's vertical. We didn't change anything. So in the maintenance perspective, there's a huge difference between typical solar farms or commercial solar versus the BIPVs.
So what if someone comes to you and wants you to take on the roof? What do you say?
We do supply roof as a material. We, as part of our production line, we use it as a buffer production. If we have a large production, there's a stop for 2 days until we start the next one. Those buffers, we produce a standard solar panels with the frame, and then we supply them. But the maintenance is something they need to keep in mind. Like for our roof, now we have kites flying, and every couple of months we have to go clean them to make sure we keep the energy flowing. It's not a major cost, but we have to be aware of it and we have to be mindful as we are installing on a roof. We do have several clients. They are major commercial and industrial builders that they are utilizing the roof. And to be honest, BIPV is not for every type of building. It has its own niche. And if someone is building an industrial building, which is like 1 or 2 story, they have a massive roof, why not utilize the roof first before thinking about the building material? So there are things that we try to educate our customers. And all these massive industrial builders, the reason they came to us is the EV adaptation and electric trucks are coming. So they did a load analysis. They realized with all the trucks that are becoming EV in the next 10 to 20 years, the power they have in their building, and even with the solar on the roof, it's not enough to create the charging station for all the trucks. So they are thinking, where else can we draw power from? We are offering them some solutions for the facade, but that's limited to the one with this kind of foresight, that is the EV adaptation and the trucks that are coming. Most of these industrial builders and most of these buildings, especially think about distributions and warehouses, they are not consuming a lot of electricity. They don't need a lot more electricity than what they consume. And that's how we optimize our models. When we model a building, we look at how much they're consuming, how much should we generate. We want to balance them out. So if there is a need for the batteries, that's a calculation we can add. If not, they can just add to the existing, call it common area, consumption.
I would think you would get max output or efficiency if you're working in ideal conditions in a new construction application where they're designing with your product from day one and optimizing everything around it, the elevation, so forth. Why do you think you got early traction on retrofit projects?
I think it's the ease of implementation. It's a lot easier. There are a lot less layers we have to go through when it comes to retrofit. There's an existing building, it's a brick building. Our material is lightweight, very simple to integrate. Versus new construction, we have to usually work with a curtain wall or a window company, or even if it's a facade, we have to work on a whole building envelope. And those are long-term. We have in our pipeline more new construction than retrofit. but our retrofits are the cycles are a lot shorter. Within 6 months, the whole cycle closes from beginning to the end. Versus new construction, there are projects we are finalizing this year as execution. They started 2 years ago. There are projects we are doing next year or 2028 that we are in the planning stage now. It's the nature of new construction, as you guys know, but the traction we get in retrofit is basically any customer, they can walk into our office, talk to our team, get an estimate, come up with a solution, they review, and within 2-3 months, they are executing. So very short sales cycles.
And I noticed on the website that you guys have color choices for the panels, which is very interesting. So is it thin film? Are you guys actually producing the panels in-house?
Yeah, we manufacture our own panels right here,
That's
but they are
awesome.
not thin film. They are, we have the thin film, but everything you see on our website is monocrystalline with the colors on top. You won't see the cells, you won't see the wires. And that's one of the comments we get when we do actual site mockups for projects. Usually architects and the owner, they're asking us, so where are the cells? Where are the solar panels? You know, you don't see them. And that's part of just educating the market. They are not supposed to be seen. It's supposed to be hybrid, hidden, and embedded into the building envelope.
How much, that's what I was going to say. Effort is being put into aesthetics right now. Are you guys, pushing what works? Are you guys trying to gather as much feedback from architects to understand how do we eliminate some of that friction from the design community?
Yeah, so Adrian, our material, first and foremost, is a cladding material. It's a construction material. It has to look good. It has to be easy to install. It has to be designed to work with all other elements of building envelope. Electricity is the bonus. So when I design or when I talk to a client, first, I make sure they understand the needs of the building as an architectural piece. It has to look good. We are not compromising anything on that level. Second one is, so what is your energy need? Let's balance it out. That's the type of conversation we have. But our job, our main core business is to create these sustainable building envelope materials. Now, the sustainability in this product comes from the PV and the photovoltaic layer.
So I can't speak to the Canadian government. I can speak to some of the local incentives here, but just in terms of like getting DOE grants or PACE financing or something of that sort, Eliot, do you see this as being, viable solution to NYCHA housing and existing buildings from that perspective?
From what I saw on the website, and it's the website, but it looks like a architectural panel, like a Kynar metallic, but deep depth, a lot more depth to the panel. I'm assuming it's glass, right? The outer skin.
Yeah,
it's what everybody's
glass,
looking for. Shadow box. It looks like that shadow box panel that everybody wants to see in their spandrel areas. And yeah, I think aesthetically they look like they're hitting the mark. And I think within reason, people have to realize that this is primarily, as Daniel said, a cladding material that you're getting electric generation from. It's not replacing, a rooftop array for power generation, I'm assuming, right, Daniel? It's utilizing the space that was just underutilized before and saying, hey, if we could pick up X kilowatts, let's do it, instead of just using that space for disguising concrete and steel.
I mean, when it comes to efficiency and sustainability, number one is insulation. If we don't have proper insulation and R value and the building envelope assembly, it doesn't matter how much BIPV or solar I have. Then how much solar you have on your roof? Do you have a roof? Do you have a space for it? The third one is the BIPV and the skin. And that's how we are guiding the same clients in the same kind of a manner. But in our architectural boxes at the same time, we have corner pieces, we have textures, satin and textured material. It's an architectural product.
It really is. It was good looking. The samples I saw on the website, it is an architectural product first. It really is.
Last year we sent 10,000 samples to architects. Tiny samples, but it's an architectural product. They need to see it, touch it, feel it. Once we get through that layer, the corners and the edges and the finishes, then we can talk about power generation and electrical wires. Then we can bring out the case studies and alleviate the pain or the misconception of what happens to the wires. Those are the things that comes kind of at the end of the conversation, not in the beginning.
So in your eyes, what's really going to drive mass adoption with any of these technologies, whether it's dynamic glass or vacuum glazing or whatever? You got to get it cost competitive with the market at scale. Obviously, that's what people are going to ask first and foremost. Is it driven by code? What are the incentives? Who's going to be raising all the objections or risk and saying you can mitigate your risk by just sticking with standard building practice? Right now, are you hyper focused on finding specific clientele? Is it more geographically driven, code driven? What's the focus?
We are mainly focused on the customers and clients who are holding on to their assets long term, such as REITs, universities, hospitals, airports. Those are the main clients because they understand the true operating costs down the road, as well as, it's their asset. This is a long-term investment. So that's number one. Then number two, as you know, in construction, cost. Cost is number one. We have to make sure we are cost competitive. We don't want to be a luxury product. We could have built a much smaller production and a business if we just wanted to be a niche provider of panels. We would price them at hundreds of dollars per square foot instead of tens of dollars. We are intentionally bringing it down to a commodity section because we want more adaptation. So cost is one thing. Number two, as you mentioned, Eliot, is the architectural piece. We need to make sure the architects, first and foremost, they understand it, they like it, they want to implement it. And the third thing is the power generation from the owner perspective in the decades to come. It actually matches all the expectations. So we have done tons of studies to prove if I claim this panel is 100 watt, it's 100 watt and it's going to be 100 watt for the next 25 years. We just updated our life expectancy to 60 years because when we are going through all this advancement and development we have done between our glass, between our aluminum and all the layers we're putting and encapsulating together, this material should last 60 years, which is the lifetime pretty much of a building.
The more vertical you go, is it more beneficial just in terms of optimization?
The more vertical we go, not necessarily. When we go vertical, it's a vertical solar farm from the PV standpoint. So first we design a vertical solar farm, and then we hide it through the layers that we have, and then we sandwich them together to build the cladding. So in a way, because of the way we compost and we kind of the composition of our material, we are getting few percentage point more power because of the air ventilation and the heat dissipation and the rain screen applications that we have versus in application that you have to encapsulate them and kind of the heat works against you.
On
in
a roof.
Dubai, on the roof, yeah. Such as the reason, for example, all those tiles on the roof didn't work. One of them is heat. You can't trap the heat and expect the solar to. Yeah.
Yeah, solar production goes down as heat goes up on the panels, and having it with a rain screen air cavity behind it is really genius idea to cool the back of the panels. It really is.
Yeah, the cooling effect is really good. Also, the fire testing. No one ever thought about BIPV and the fire testing before until we started. The first thing we did, we went to an FBA 285. That was the first. We booked the lab for 2 weeks. We tried different iteration of BIPVs and compositions and what works, what doesn't work. Then we came up and we said, okay, now let's design a product. Right now we went above and beyond because in Middle East market, they want non-combustible solar panels. They want non-combustible BIPVs because of all the issues they had. So 2 years ago, we designed the non-combustible version for the region just to make sure we can address the need. So when you ask me about the code, there is no code that can prevent us from going into any market, whether it's Miami-Dade or it's Middle East in Dubai or Saudi, or we just go to New York. We have covered pretty much all bases in the past 4 or 5 years. We got all the certificate, all the testing. So the code is not stopping us, but also is not helping us because there is no requirement. There is no, to be honest, if I was writing the code, I can't put something in a code that doesn't exist. So now that we exist, now that we are doing, I'm hoping that change comes after. There should be some sort of minimum requirement. 5% of energy need can be produced on site. 10% can be produced on site. Even if you don't have a roof, the roof could be a green roof. We don't want to go on a roof necessarily when you are a high rise. We have the numbers. Any building over 6 story, it doesn't make sense to go on the roof. Once you hit 6, you better go on the cladding, leave the roof as a living space. It could be a green roof or anything else that you want to utilize. But below 6, if you're 4, you better put the solar on the roof and maximize the energy generation through the roof application.
If you were pitching this to DOB, Elliot, what would you say? What could be an avenue to integrate this into code?
You know, I don't think there's a limitation now. Integrating it into code, I don't think is the answer. To be honest with you, the reason why me concentrating on the architectural and aesthetic aspect is people aren't going to put vertical solar into their buildings solely as an energy efficiency measure. People are going to look for, I'm building a building, I'm recladding a building, I want it to look good. If I can get a megawatt over the whatever it is over the lifespan, and it's costing me X number more than a good cladding system. If you compare cladding systems, if this is, at the top two-third cost wise, I'm assuming, right? It's a no-brainer. You're getting it not for free, but at a minimum charge when you've already committed to doing a renovation or to building a building. The premium you're paying for this, it's the only time it's really worth it is when you've already decided to do it. So I think I think he hit a home run with it by looking at appealing to people's aesthetics first and then giving them the bonus of the electric, because people don't even understand what a 100-watt panel means, right? They just know they're getting energy from it, and we should encourage that. I don't know that we need it to be in the code. I think there needs to be incentives. I think we need to give people incentives to say, here's what an Alucobond panel on a rain screen wall costs to get here so that you could generate your own power. Let's give them an incentive to do that, whether it's tax breaks over the next 20 years, whatever it is. I think that's the direction we need to go in. Incorporating this into the code, it doesn't, I don't, correct me if I'm wrong, Daniel, you don't get enough generation to move the needle as a energy generator. But when you consider that it is your cladding and it's got built-in energy generation, that's a great thing. And I looked at the Cladify website. You guys have a lot of experience cladding buildings, so that's also really, really unique because, like you said, people on the solar side or the ESG side don't know anything about construction for the most part. We see some crazy things happening out there in the name of energy conservation or energy efficiency, and you look at it and you're like, well, that's not efficient at all. But this is something that we know how to do, and we're adding that benefit to it.
You're right on the 2 points that you mentioned. Hitting people with first starting on aesthetic and the construction material and the cladding, it's a home run, but we didn't hit the home run right off the bat. This wasn't our first swing. We tried many different approaching it, and this one we realized we just went back to basic. We said we are selling other materials. What are we selling? So
exactly.
Why are we trying to change our approach just because the material is doing something else? So we kind of adjusted and pivoted back to the core and to the basis.
To your strength.
That's exactly. So that's what the material is. And I think I was reading Bloomberg's biography, Michael Bloomberg. That's when kind of it hit him when he was in his lows. He couldn't figure out the platform. He couldn't figure out the data. And then bottom line, he realized, he said, my business is selling data. Why am I focused on the computer? I'm selling data. Who cares about the computer? Anyone can build the computer. He switched and his business took off. This was like, a couple of years ago. As I'm reading his biography and I'm thinking, what is our business? What is Mitrex? It's a cladding material. So why are we always pitching about energy and, all this and that? Let's sell the cladding material. The energy is the bonus. That's when things start to work out a lot better.
Monocrystalline cells are ugly. They're ugly. He's taken something that's ugly and made it nice looking and presentable to the point where I'm going to put this on my building. I want to put it on my farm. I'm going to talk to you after the call. Believe me, we're trying to get in before the end of the year and we lose our incentives. But it's definitely something that I think you guys hit a niche that didn't exist. You created it.
Yeah. For the ROI that you mentioned also, it really depends what material are we comparing ourselves to. There
Correct.
Are some projects we go to that their ROI is infinite because our material cost and everything is the same or sometimes lower than what they originally wanted to use. Some terracotta, some
Yep.
Porcelain material, some limestone, natural material, even some high-end aluminum materials, metal panels. Our panels are the same or less expensive. So those are really easy. But when we go to some applications that are just using EFS or stucco or low-cost material, then we can't really compete. But what's funny is even in our worst-case scenario, the ROI is still 5-6 years. It's not like they have to wait 15-20 years. 5 to 6 years, they get the whole investment back. And for the next 20-30 years, it's all profit moving forward. One of the reasons, again, we focus on these verticals, as I mentioned, hospitals and airports, because they never choose those low-cost materials either. They're
Correct.
working with proper materials. So the ROI is just a, simple calculation.
There is no ROI on traditional facade materials. You purchase it, that's it. At least this has an ROI. Other things don't have an ROI at all.
From energy perspective, then from EPD, we are just releasing our updated EPD, third-party EPD. We have some of the lowest carbon embodied materials in our kind of comparable materials, mainly because we manufacture them in a very clean and renewable energies that we have. So we are using renewable and clean energy to produce more renewable materials and sustainable materials. So it worked out really good to our advantage from water recycling, electricity, all of those came together. I think we're just sending a couple of email blasts in the next few weeks just to talk about how low of a carbon embody we have.
I think the 60-year life cycle is huge, though. I mean, anything that you can average out over 60 years, even if it's not low initial carbon, if it's high initial carbon, spread out over 60 years, it's a no-brainer. Nothing lasts 60 years anymore. If you get 30, it's a miracle these days. And honestly, even if your system had to be upgraded after 30 years, 30 years is a long time for a building product.
Somehow you lasted 60 years, but
exactly.
What in terms of integrating now into because this I'm really interested in. Anytime you introduce some atypical material or assembly into the unitized curtain wall world, you're going to get friction. They don't want it. They want to work with aluminum and metal and what they're comfortable with. So let's say our owner architect is dead set on using you. What's some pushback you get from the unitizers? What additional steps have to be taken to integrate it into the curtain wall system?
Yeah, you're right. We tried working with many curtain wall and unitized companies, a few years ago, and it was
they
all
don't care.
They don't care. It doesn't go anywhere. But also in a decision making, if you look at the hierarchy of decision making, they are not making decision for the material. They're executing on what's already been decided. If there is a curtain wall, they with the aluminum and a glass. So we realize that's not the right approach. So there are two areas right now we receive orders that we can process. Number one, IGUs that the architect wants a certain IGU with the spec, and they want the solar embedded ready for implementation. Those are fairly simple because we supply the glass. The only challenge is usually the schedule. Their schedules, we have to start a couple of months ahead of everyone else because we have more layers to assemble. Once we hit the schedule, there isn't much after that. It's a fairly simple integration. Number two, fins. There are a lot of fins that we are working on that gets integrated into the curtain walls after. We supply the fins and then they kind of assemble it together, either in the curtain wall company or on site, depends on the application.
And wiring is designed by you guys too?
Yeah, we kind of design the wiring once we have the shop drawing. All these curtain walls, they have a lot of space that we can utilize, and they have their own recommendation. Our wires are only 1/4 inch. It's only 1/4. You can fish them through many areas, and they go through many conduits that we create.
Are there any projects in New York City I could go look at tomorrow?
Nothing tomorrow, but I think in the next few months there will be a couple of them that are being installed. In Jersey, there is one. They are almost completed. It's a smaller project. I think it's a 5-6 story building. But in New York, there's a library and a couple of other projects that they haven't installed it yet.
Very exciting. It's very cool. So any message you want to get out there anywhere, just in terms of, I think there's a huge opportunity when it comes to just education and spreading awareness here on our domestic side. It's hard to crack Eliot, so the fact that you got him excited is very cool. But yeah, just in terms of like what what's the best resource? I mean, the knowledge sharing has to be straightforward. I started this conversation by asking what's the 30-second pitch, and 15 seconds in, the light bulb has to go off, or people are just going to immediately dismiss it. So where do you want to drive people's attention? Is it to the website to display or demonstrate the aesthetic capabilities? I didn't even know that, how sort of, I'm not an architect, but how designer friendly the material is, which I think is awesome. Where do you want to drive eyes and attention at the moment?
So yeah, number one is our website, and there are samples available on the website that anyone can just order and see the different colors. So I think it's one of those underutilized sections of our website. Even though we have done tens of thousands, I think it should be a lot more. Number two, case studies. A lot of case studies on our website that everyone can download. There are projects with addresses, with information that they can actually read and understand how we did it. And the third one is the design assist. We do design assist on regular basis on many projects. Clients, they come, they have the want and the need. We put it all together. We create a whole building together as a partnership. And in a year or two, we will see the results as an actual project. We started our design assist on our other product with Clarify, but now we are doing a lot of design assist on Mitrex too. So I think, getting the samples, reading the case studies, and helping them with the project, that's a successful project. That everything comes together.
Daniel, you guys provide a complete system, not just the glass, right?
Correct. So we can just supply the panels, or we can supply the full system. And the system is our system, is our thermal brackets and our L-bars and insulation on rain screen. We also have a prefabricated solution. We are doing a couple of hotels, prefabricated BIPVs, that BIPV insulation, which is a rain screen prefabricated. It all comes as a package to the job site, a slab to slab connection, the rest is a standard process, but the BIPV is already part of the panel.
Could you see yourself wanting to get into the installation side of the business down the line?
Adrian, I see myself doing anything until for this one become a standard construction material. If I have to get into prefab, we are doing installation on an occasional basis. We take the full contract. Obviously, we subcontract it to installers, but we take the full responsibility and liability because we want those specific projects to be done. We want to make sure that building.
You want it on the building. That's what's going to sell it.
That's all we need. We need one building, a good building, one monumental building in every city. We just launched a new building. It's going under installation in Dubai. It's LED integrated BIPV. So during the day, absorbs the electricity and energy from the sun, and at night, it emits and it's kind of illuminates at night. So those are the projects we do, not because we want to keep getting into more complex project, because it sends a message. Now you can do this. If you can do that, then what's a typical aluminum panel? Like, that's the easy one. Now let's do the aluminum ones.
Yep. All right. Well, thank you for coming on. This was awesome. I'm excited to chop it up and share it. But great story. It's awesome what you guys are doing. So a lot of credit there.
Thank you, Adrian. Thanks, Eliot, for arranging it. And it was great meeting you both.
Of course.
Same here. I'm going to actually email you. I was serious about getting some for my place.
All right. So there's an ROI on coming on the podcast.
There's an ROI coming in.
All right. Thanks,
Sounds
guys.
good. Thank you, guys.
Thanks, Daniel.